Unit 9, Lesson 1, Radians and Degrees. If you've not already done so, please go to the homepage and click on the tutorial that explains how to quickly identify the degree and radian measurements of a unit circle. And this is the product of that quick tutorial. Now, what I do need to mention is, as I said in the video, this is the starting point. And when I see a positive degree measurement, I am moving upwards. Now, we can revolve around this unit circle an endless amount of times. For instance, if I know 1 revolution is 360, then I know 2 revolutions is 720. Now we can reverse it and go clockwise, so spinning downwards instead of forward if the measurement is negative. An example, positive 30 degrees can be found right here. Negative 30 degrees, I'm going to take 360 and subtract 30. So when I see a negative measurement, for instance, if I have a negative 45 degree measurement, I will take, let's see, move it so you can see it better. That is really glaring for you. Let me see if I shut off the lights here, if that helps. Give me 1 second to open up a window and see if this helps any. That does not seem to work. Maybe I will pull the calculator up on the screen here. But anyways, if I take 360 and I go ahead and I subtract 45 or add a negative 45, I end up with 315. So a positive 45 ends right here. A negative 45 is going to take that same measurement but reverse it and go clockwise. So our natural movement around the unit circle is counterclockwise. And when we see a negative measurement, we just reverse it. Positive 90 degrees, negative 90 degrees. Positive 2 pi over 3, negative 2 pi over 3. Let's take a look now at problem 1 from lesson. So if we look at our unit circle, you could quickly identify where to find 120 degrees. Now, I know I'm breaking this up real quick, and I'm breaking this up by 30. So I have 3, 6, 9, 12. This will be where 120 lands. Now, 120 is in quadrant 2. Most often with math authors, they're going to identify the quadrants as Roman numerals. So yes, it is quadrant 2, but I do want you to become accustomed to seeing that as a Roman numeral. Now let's convert this into radian measurements. So I'm going to count here, and we will have to be able to do this by heart, so we're going to go through this slowly. Whenever I look at 30 degree increments, it's the same as having 6 on the bottom. So here's 1 over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6. This is 4 pi over 6, and that reduces to 2 pi over 3. Let's look at number 2. So I'm going to look right now, and I'm going to try to find 30. So counting by 30s. We know that in each quadrant it's 90 degrees, and it's broken into 3 30-degree measurements. So I'm counting by 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27, and here is 30. So this would be 300 degrees. Now this lands in quadrant number 4. And how do we write quadrant 4? It is IV. That's quadrant 4. And now we need to convert 30 degrees into an equivalent radian measurement. Once again, when we are counting by 30s, a 6 is on the bottom. So first I'm going to figure out the measurement, then I'll reduce that radian. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pi over 6, both even in the numerator and the denominator, so I'm going to divide both by 2 to get 5 pi over 3. Let's look at number 3. I recognize this as being a 45 degree increment, and so I know it's directly here. So it's in between 180 and 270 degrees, directly in between there. That is in quadrant number 3. And now I'm going to convert this. So this is in terms, whenever we do 45s, 45s are going to have a 4 on the bottom. So 1 over 4, 2 over 4, 3 over 4, 4 over 4, 5 over 4. 5 pi over 4. Let's find 270. 270 is divisible by 3. Since it's divisible by 3, I'm going to start by counting and identifying the 30-degree marks, and I'm going to count by 3 to make it easier. 3, 6, 9, 12, 15, 18, 21, 24, 27. All right, this does not lie in quadrant 3 or quadrant 4. It is on this axis. Now what we're going to learn is we are so accustomed to seeing this and thinking of this as what axis is this. Later we'll learn about these axes and what they're named, but this is lying on an axis. Let's move this over to. All right, so let me pick up here before I go to 5. So this does land on this axis, on the y-axis. Let's go now to 390. Okay, so is 39 divisible by 3? 39 is in fact divisible by 3. So I'm going to go ahead again and I'm going to count by 3s. Now you may feel a little confused here. And the reason for it is when we look at the unit circle that we filled out in the tutorial before this, I stopped at 360. That doesn't mean I can't continue. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39. So it's one revolution plus an additional 30 degrees. I'll demonstrate that here. So first I was able to identify that 39 is divisible by 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39. So when we think about this, remember, we're going all the way around one time and then stopping right here. So this is in quadrant 1. This is in quadrant 1. And now we need to convert it into radians. Now we have a couple different ways we can do this. I know 1 revolution is equivalent to 2 pi. Now how do I know this? 1 over 6, 2, 6, 3, 6, 4 over 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10 over 6, 11 pi over 6, 12 pi over 6. Well, 12 pi over 6 reduces to 2 pi. So I have 2 pi or 12 pi over 6. So maybe it's even easier to write 12 pi over 6 and not reduce it. And now I need to add to it one additional 1 pi over 6 because an additional 30 degrees is equivalent to 1 pi over 6. And I end up with 13 pi over 6. Now, what do we do when we come up with a degree measurement or a radian measurement, in fact, that's not one of the memorized 30s or 45s? It doesn't mean we can't find it. Like I added, there's 15 degrees here. Here's 20 degrees. And it does have, we can convert it into an equivalent radian measurement. Let's go over how to do that in problem number 6. Let me grab a piece of paper. As a reminder, part of your advanced placement pre-calculus exam, you will not have access to a calculator. So it is important that you know this process as we go through this. Half of the exam, you will not have access to a calculator. So let's first figure out where is 270. I know 180 is half of the unit circle. So if this is 180, it's going to be slightly before 180. This lands in quadrant number 2. And now let's convert this into radian measurement. So to convert from degrees to radians, I'm going to take this specific degree measurement times 1 pi over 180 degrees. And then we would go about reducing these measurements. Now, if I had a calculator in which you could see the screen, oh, there it's working. Awesome. Oh, there it goes off. As soon as I hit clear, it goes off. So let's see if this works one more time. If not, I'll pull up Desmos and show you. If I take 172 divided by 180, I hit the math key on the left, press enter twice. It's going to reduce it to 4 pi or 43 over 45. You can't see that on my calculator. I don't know why it's glaring. So I pulled up Desmos to show you. So I'm going to take 172 divided by 180. And if I push this little fraction key in the left-hand side, it will reduce it down to 43 divided by 45. That's exactly what I have in my calculator. So this is going to convert to 43 pi over 45. This is equivalent measurement to 172 degrees. As a reminder, just like length, we can measure length or distance on a map in terms of kilometers or miles. We can measure interior angles of a unit circle in terms of degrees and equivalent measurement of radians. Let's look at number 7. Number 7 may stump you because we know one revolution around a unit circle is 360. One revolution is 360. So how many times do I have to go around, and then what's left over? So let me pull up Desmos. That may be a little bit easier, and I'll clear this. So I'm left, let me just make sure here, of 840. So I have 840. I'm going to subtract one revolution, one time around a circle, and I still have more than 360. So I'm going to subtract again. So, oops, let me go back here. If I take 480 and I subtract 360, another revolution, I'm left with 120. So I can see here I go 2 revolutions, so 2 groups of 36 and then 120. So if I add up 360 plus 120, I end up with 840. So I'm able to break apart 840 into, there's 1 revolution, there's a 2nd revolution, and then I have a portion of a unit circle, which is 120. So I'm going to go 1 time around, 2nd time around, and I'm going to end at 120. Now 120 is divisible by 3. 12 is divisible by 3. 12 divided by 3 is 4. So I'm going to count in terms of 30s. 1, 2, 3, 4. This is where it lands. Okay, so this lands in quadrant number 2. And now we need to convert 720 or 840, excuse me, into a radian measurement. Now I'm going to show you what most people choose to do, but I'll give you a couple options on how you best are able to do this. So 840, I can take 840. Again, when I'm going from degrees into radians, I'm going to multiply it by 1 pi over 180 degrees. And then I'm going to come back and do 840 divided by 840 divided by 180, and when I press this, it reduces automatically down to 14 pi over 3. 14 pi over 3. So this is 14 pi over 3. 14 pi over 3. Now, is there another way to do that? Let's check and see. Well, I have 2 revolutions, so I know each revolution is going to be 2 pi or 12 pi over 6 if I don't go ahead and break it apart. This is an alternative way to coming up with the same answer. So there's 1 revolution, there's a 2nd full revolution, and then 12 or 120 would be 1 over 6, 2 over 6, 3 over 6. This would be 4 pi over 6 plus 4 pi over 6. I have a common denominator of 6. 12 and 12 is 24. 24, 25, 26, 27, 28. I have 28 pi over 6. Oh, they're both even. Divided by 2 to get 14. Divided by 2 to get 3. We get the same answer. You choose which way makes more sense to you. Now notice when we look at number 8, the first thing I want to notice is that we do have positive. So I'm starting here and I'm moving up. We can see as I'm going through and I'm finding these angles that are more than 1 revolution, I'm always starting and going up first. When we have a negative measurement, let's locate 1395. How many revolutions will that be? 1395, 1395. All right, I'm going to subtract. Well, actually, you know what? I think even easier. I'm going to divide it by 360, and I can see that I have at least 3 revolutions, and then there's a portion remaining. So if I take 395 and I subtract 3 groups of 360, so I could take 3 times 360, or maybe you want me just simply to subtract 3 times. I'm left with 315. Okay, so 360, 360, 360, and 315 should add up to 1395. Let me prove that to you. Whoops, let me go back here. And we can see that adds up to 1395. All right, so this is equivalent to 360 plus 360 plus 360 plus 315. Okay, so I'm going to do 3 complete revolutions. Here's 1 revolution, 2nd revolution, 3rd revolution, and now I need to end at 315. Now 315 is directly in between 270 and 360. It's going to be right there. So I come around, it's one of those 45-degree increments. So this is in quadrant number 4, and we write that as a Roman numeral. Remember that most math authors, when we look at professional tests, will use the Roman numeral, so get used to doing that. And now let's convert it from degrees into radian measurements. 1395 times 1 pi over 180 degrees. I'm going to jump back here into this position, and let me just erase this so we have less. And I'm going to take 1395 and I'm going to divide it by 180. Pressing this, you can do the exact same thing on your graphing calculator, hitting math, fraction, enter, enter. 31 over 4. Now don't forget about the pi. So 31 over 4. 31 pi over 4. All right, now we're going to get into negatives. So negative measurements just means instead of going up, we're going to drop down first. Let's take, when we look at number 6, I want to first think to myself, where do I find a positive 60? So this is divisible by 3, so I'm going to count by 3s. 3, 6, it would be right here. This would be a positive 60. So I need to reverse direction and go down. So down 30, down 60. This is where it is. So this is in quadrant number 4, written as a Roman numeral. And now let's convert this into radian measurements. So I'm going to take 60 degrees and a lot of wrestling from my kids in the background. Sorry for that distraction. Okay, so let's convert this now into radian measurement. So I'm going to go 60 degrees, and a couple different ways we can do this, and I'll demonstrate both. I'm going to take it times 1 pi over 180, and I can do this quickly. I get 60 over 180, and dividing it by 60, I end up with 1 pi over 3, right? Or, again, since I can't show you on the calculator since it glares, I could take 60 divided by 180. Whoops, so sorry. 60 divided by 180, hitting the fraction key, and we get the 1/3. But now here's the key. Well, if you saw a positive radian measurement, it means we're going up, but we're going down. So negative 1 pi over 3. Let's take a look at number 10. But I do want to show you another way. I'm sorry. I was distracted by my kids. Another way to do this, and this is correct, make sure it's negative since we're dropping down, is to come up here and we're going to count. This is 1 over 6, 2 over 6. So I'm dropping down 2 pi over 6. Again, it reduces to negative 1 pi over 3. Let's take a look at number 10. All right, let's identify where we can find negative 300 degrees. So in my mind, how am I thinking of this personally? So as I would begin here to understand trigonometry, one way you may choose to do it is go, well, where is a positive 300? 3, 6, 9, so I'm going for 30. 3, 6, 9, 12, 15, 18, 21, 24, 27, 300. So a positive would go here and land at this position. But because it's negative, I got to do just the opposite. So I'm going to go 1 quadrant, 2 quadrant, 3 quadrants, an additional 30. 1 quadrant, 2 quadrants, 3 quadrants, an additional 30. Is there another way we could do that? There is another way that we could do that. We could take 360 and we're going to add a negative 300 to it, and that's another way that we could do this. Let's see if I'm trying to put my calculator any way that you could see that'd be helpful. Let's see if it adjusts here to there we go. So we can see that if I take 360 and I add a negative 300, I also end up with 60, which is right here, and it tells me how to get to that position. So starting here and reversing. So this lands in quadrant number 1, written as a Roman numeral. And now let's convert this. So I need to convert this here. I'm not going to convert 60. That's a common mistake. Students want to convert 60. I'm going to convert a negative 300. So let's just start with 300. How do I get to this original position? If I counted and went 3, 6, 9, 12, 15, 18, 21, 24, 27, 300. Like, how do I come up with that? Well, remember that when we count by 30s, we're counting by 1 pi over 6. So I'm going to do that way. And I'll show you another way you do using algebra as a secondary option. Okay. 1 over 6, 2 over 6, 3, 6, 4, 6, 5, 6, 6, 6, 7 over 6, 8 over 6, 9 over 6, 10 pi over 6. So I had to reverse it. So negative 10 pi over 6 which reduces to negative 5 pi over 3. So if we go here and we count backwards, we should count 10 pi over 6. So here we go. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pi over 6, it was reverse directions. It reduces down to negative 5 pi over 3. Maybe that's confusing to you. And if that's confusing to you, well then let's go ahead and let's do 300 times 1 pi over 180. I'm going to grab decimal since you cannot see the calculator well and type in 300 divided by 180. That did not show up. 300 divided by 180. And remember to put the negative sign in front and attach the pi to the numerator. So negative 5 pi over 3. Negative 5 pi over 3. Let's take a look now at. So I'm first going to think of this simply in terms of 495. The negative sign just means we're going to reverse directions. Instead of going counterclockwise, we're going to go clockwise. So I'm going to come over here and 495. So if I was new to the unit circle, I'm taking 495 and I'm dividing it by 360 to figure out how many revolutions am I able to achieve. And I can see I'm able to achieve 1 full revolution plus a little bit more. So if I take 495 and I subtract 360, I get 135. What does that tell me? Okay. So this is equivalent to negative 360 plus a negative 135. This would achieve negative 495. Well, where is 135? 135, if there was no negative, it's a 45-degree measurement. It's this one right here. It's 1 full 90 plus a 45. So if I did not have negatives, if I did not, I would go 1 full revolution, and then to get to 135, it would be 90 plus 45. It would look just like this. If I could erase it, let me grab a pencil. If this was positive, it would be 1 revolution, and then I'd go up to 135, right there in the middle. But it's negative. That means I need to reverse it. So I'm going to go reverse 1 revolution. And now to get to a negative 135, it was 90 degrees plus an additional 45. This lands in quadrant number 3, written as a Roman numeral. And now let's convert it. So most of you, when you have access to a calculator, are probably going to prefer just to take 495, because what we're doing is we're taking 495, we're multiplying times 1 pi over 180, and then don't forget to drop down the negative sign afterwards. So I'm going to come up here and take 495, and I'm going to divide it by 180. Whenever we go from degrees to radians, that's what we do. And I need to simplify it. So 11 pi over 4. Now here are 2 things not to forget. The negative sign and the pi in the numerator, 11 pi over 4. Let's take a look at number 12. I'm going to do 12 just like I did number 11. It's more than 360. Forget about the negative sign. It's more than 360. So I want to ensure how many revolutions. Now I know this because I've worked again with trigonometry for most of my adult life and starting when I was in high school. And so I know that 1 revolution is 360, and 360 plus 360 is 72. So I know it's going to be just a little bit more than 1 revolution. But if you weren't sure about that, you could take 450 and divide it by 360, and you go, okay, it's 1.25. And some of you have already thought in your head, 0.25 is a fourth of a unit circle. So some of you may even already know where this lands. So I know I'm going to have just a little bit more remaining. So I'm going to take 450 and I'm going to subtract 360 to end up with 90. So I'm going to be able to break this apart into negative 360 plus negative 90. Okay, negatives means I reverse. So 360 is 1 revolution and 90 is going to end right here. So where does this land? It actually is going to land on the y-axis. It's landing on the y-axis. It's not in a quadrant. It's not in a quadrant. It's going to be on the y-axis. And now let's convert it. So whenever we go from degrees into radian measurements, I'm taking, in this case, 450 times 1 pi over 180. Remember, my final answer is going to be negative with a pi on top. So I'm going to come back here, sorry, and then I'm going to take the 450 and I'm dividing it by 180. And then I'm going to reduce to 5 pi over 2. And don't forget about the negative sign. Negative 5 pi over 2. Sometimes students ask me, does the negative sign need to go in the middle at the same level as the division sign? Does it go up top? Does it have to be top and bottom? As long as there is one negative sign, you're fine. Some students prefer to put it up top. Professionally, we generally put it at the same level as the division sign.